All right. We're going to have a look at another example of a slope field and solution graph. For this example, we are going to consider the field. Okay, and we're going to actually give ourselves an initial condition as well. All right, so we're going to sketch the slope field, and then we're going to use the sketched slope field to try and work out what the solution looks like given this initial condition. So let's just begin with our axes. And again, take a bunch of test points. And obviously we'll look in these quadrants as well. And we'll try and work out what this thing's going to look like. Again, you know that we're just trying to work out what the derivative is at fixed point. So we can go ahead and do a few of those obvious test points. And see what we see. So I noticed a bit of a pattern already. I've noticed that on some straight line, some inclined straight line through the origin, I'm going to get zero derivative. So at the origin itself, I've obviously got zero derivative. At -1, 1, which is here, I've got zero derivative. At -2, 2, I'm going to have zero derivative. At 1, -1, I'm going to have zero derivative, and so on, right? I'm going to have a line of zero derivative through there. Okay. Now, at 1, 1, I guess we've got 2, so I can draw that one in. So it's quite a steep line. At 2, 1, it's going to be 3, so it's going to be a bit steeper. These ones are going to be steeper again. No, that one's going to match with that one, obviously. But that's sort of what the derivative in there is going to look like. Out here, let's say at this point here, we're going to have a slope 1. It's going to be -1 plus, slope 1, yes, -1 plus 2 is 1. So that's going to be like that, approximately. Again, resolution is not our friend when we're doing this by hand, so it's not going to be a great picture. Down here, obviously, is this quadrant's going to match this one, roughly speaking. 2 minus 1 is 1, so we're going to get a slope 1 there. Here, we're going to get slope. Here we've got here we've got negative slope. So x is 1, y is -2, so that's going to be a slope of -1. At 0, -1, we've got another slope -1. At -1, 0, we've got slope -1. So we have this other line here where we've got slope -1. What's happening here? We've obviously got slope -2 and so on, right? So if x is -2 and y is 0, we've got -2. Here, I guess that's going out that way. So at x equals -3, y equals 1, we've got slope -2, and so on. Here, x is 1, y is minus. That looks like y 0, -2, yep, like so. I've lost my point. X, yep, -2 again. All right, and we can sort of fill in, I'll just fill in that one, and that one. That should give me a pretty complete looking picture. Oh, I should go and draw in those ones as well. So here we've got -2, so that's going to be slope -3, so that's quite steep. That one's going to be -3 as well. This one's going to be -4, so it's even steeper. Out here we've got slope 1. Here we've got slope 2. Here we've got slope 1. Here we've got slope 2. All right, and you can tell that these sketches are pretty rough. And I'll just put a nice frame on my picture, because I've kind of gone a bit overboard. Right, now let's think about where this initial condition is. At x equals 0, y is equal to 1. So x equals 0, y equals 1. Now, we pretend that t goes on forever from the starting point. So initially, our slope line is tangent to our solution, so our solution locally must look like that, but it's going to become steeper, so it looks more like that. Out here, if we let time run backwards, we see that the slope must flatten out, and locally it's got to start looking like this. So going to kind of look like that. Out here, the solution's got to start looking locally like slope 1. So that's what our solution kind of looks like. Okay.